Jai Hind to all. My name is Aarti. I'm assistant professor in AKGEC, and today's I will discuss the machine learning techniques that we will use in our BCS 055 topic. That is a subject topic, and what we are using in what is learning in it. What is learning? What is a well-defined problems we are having it? How can we distinguish between machine learning and its technique also? So in the subsequent presentation, we will discuss what is learning, what is the types of learning we are having, what are the well-defined problems we are having, and how can we design a learning system according to that. In addition to that, we will discuss what is AI also, what is the relation between AI, machine learning and deep learning technique, deep learning. These are the subset, these are supersets of all that. We will discuss it. So we will, at the end of this presentation, you will have a clear picture of what is learning, what is machine learning, what is AI, and how do we formulate any problem, well-defined problems, what is existing in it, and how can we formulate any problem which is in machine learning. So these are the 4 points we will discuss in this. So what is learning? What is learning? How can we say that any machine which we have to be? So in our journal life, in our life, what we show is learning to us. So learning is when we learn from our experience with some task. What we are having any task which is given to us, we will learn from our experience, past experience, and then according their performance is evaluated. Same in a machine learning also. So we are having a E, that is our experience with respect to any task. Any handwriting task, any robot, self-driving cars, they are having any task which is the T, and we are, according to that, we will measure any performance, that is a P. So we are 3 parameters we will use in it, that is a E, where we are performance and the task we are having. So these are the 3 parameters. According to that, a machine can learn according to that. So for example, we have a handwriting recognition problem. That is a recognition. That is a the thing is that what is a task? The task is to recognize and to classify that is what is a handwriting. For example, I may say this is also a. This is a small a. This is also a curly a. This is also a A. And this is also A. So this is we are having a task to, there's multiple ways to write a alphabet A, capital or small, any of the thing, but we will have a task of recognizing it. So performance is how correctly a computer will identify this is a A. Small a or a big A, it is a A. Okay, why we are having, so by how can we recognize it? We will give a experience which is a past experience, a data set of experience. We will feed it, and then after we will recognize that it is a A according to that. So this is a learning problem. So in any machine learning problem, what we have a experience, that is a past experience. According to that, we will make of any task, of any of the task, and how accuracy, that is accuracy, precision, these are the parameters we will have for our for the machine learning. So this is the experience E, P and T we are having for us. So another example of is robot driving learning problems. Robot learning problems, we are having a sensors. We will say that the robot will how it will drive a car without the help of human. So we will say that the driving on a highway using a vision sensors. This is a problem for us. Performance, how average distance it will cover without any error, without left or right turn, without. So what will we have feeded it input, what we have done into it. This is a experience, past experience. What we have is images, steering, recorded by us. So by us, we have recorded it, and then after we have feed to it, and then after we will have a task to drive on highways, and what is our performance? Okay, with a less number of errors, we will have a performance measure according to that. What is chess learning? Chess learning problem. We are having a chess learning. We will change in today's scenario. Also, we are playing with the games. Also, so there was a option with you will if you are not two contenders there, so you have option that you will play with a computer also with a computer. So how can there was many chances that the computer will be win that condition, but how can we this is possible? But this is possible by using that we are giving an experience, and we have a practice games by itself also, and it will learn that in every situation you have to make a success rate. So you will have a feeling that you are playing with the other person also, but it is a machine that you are playing with. So if we are having a task of playing P, and we have a performance measure with a percentage of gain against that opponent. So that opponent is a human also, that opponent is a computer also, anyone. So we are having an experience where that is a practice game which is giving to itself. So what is a formulative, what is a definition of machine learning? So machine learning is computer program that learns from experience, is called a machine learning program, and simply a learning program. So we are having a there was two terms, machine and learning, that are learning by using experience of any individual task with performance, high accuracy, high precision. Okay? And this is known as a learning program also. It is also known as, and we are having a program which is used as a learner. So there was two terms which we are having in machine learning. So machine and learning by the experience, and machine, how can it will formulate a task and give a performance, high performance according to that. Okay, so we are having a this. So what are the components of we have learning process? What are the components that are human also, machine also? So the learning process by us also, and the machine also. So in our today's scenario, what we are having the person in our life also, we will learn from our experience. If it's first one, so we will done accordingly by using our mind. If it's repetitively, so we will say that okay, beta, you will do like this because we have done earlier also, we have experienced this also in our life. So you will work according to that. So you will advise according to that. Now, so machine also learn from the experience. We are having a training a model also, and then after we will make the testing and training according to that. So we have a learning process by the human also and the machine also. So we are dividing into four components, that is data storage, abstraction, generalization, and evaluation. These are the four processes we are having in our here. So we are that 3-4 process is used for the learning process. How can we will see it in a figure. We are having a data storage. We have the data stored. Then abstraction. We have the concept are there when we are making a model of according to it. The data is raw data also, that data, and there was large number of data. Every day we are getting a data. So what data is stored, and then after we will have to have abstraction. Abstraction is making a concept of, making a modeling, making a model of it. Then after it will use it. Generalize, you are making an inference in the future also. Okay, you will do this by using this, and then we are having an evaluation of this. The evaluation is also known as feedback of it. Feedback is that though we are making any concept and we are making a model, and a model has to be make a any error, then you make a feedback that in future this situation arises, you will do this. This is a main motto of using a learning process which is used in machine learning. The first one is data storage. Data storage, as we know, there's huge number of data is stored in day by day. The human is utilizing, human is using their mind, and the computer is using the hard disk, also floppy, and all that data is to be there. So there we are having in a brain, and these the data are stored in the hard drives, external storage, retrievers, all the data is to be stored. So there is a raw data, huge number of data, TBs of data we are available. So how can we do our learning process? first we have a data. That data has to be refined by the abstraction process, that is abstraction. This is the second learning step of the learning process. So in which we are having extracting knowledge from the stored data. So the data stored in our human brain also and in the computer also, that data has to be extracted knowledge, and we are making our data as a general concept of it. We are making a concept that this is how can we do it, by using our past experience with us also, with the computer also. So we are creating a knowledge. We are making a known models. We are having that model is existing also, and we are making a new model also to make a training of the data. Because when we are doing machine learning, what we have to do is, if we are, for example, we are having 100 records with us. So what we will do is, we are having a 70 or 32 ratio. We will do it 70% we are using it for the training, and 30% we are using for the if I train a model, then after the model will recognize it and making a that the 30% is recognizing it efficiently, and the performance has to be, accuracy has to be more and more, that is 80s or 90s%. Okay, so we are in this abstraction, we are making a general concept also, we are having existing models of making a creation of the new models also, and we are making a model, that is a model which is used for the training also. So we are having a training ratio, that is training, and this is for testing, that is 16 to 70. We are also 50 also, 40, but we are making that more of training and less of testing part. That the person we are making any model, so that has to be trained according to that, and then after the testing part is there, that when we are making a model, then that model is accurate or not by using the testing data set to it, and then after that data set is categorizing according to that, and then the accuracy and the precision has to be high onto it. So we are in abstraction model, we are making a model according to that training and testing mode. That data is to be there into a data storage. The first is data storage, then is abstraction. We are making a generalized model. Next we are having a generalization. Generalization is the third process of this, in which the generalization, we have a process of turning a knowledge into stored data with our future action. But in a future, what we will do according to that? What will we have to be that data has to be done? We have model it, and then in the future, if anything comes into it, so they will act according to it. So we are having a future perspective to it. So we are having actions, we are a task, we are making a modeling of it, we are creating a new model of it. So we are having data discovery of these property of the data, that is more relevant to a task, future task. In future, handwriting problem will be identified. That, for example, if you go into a doctor, you can't recognize that handwriting because they are writing like this. So we are that model will apply to the doctor's machine learning model. So we have trained it. We have, in the future, we will apply to the handwriting part of the doctor, and then an ordinary person will read that, oh, this is this medicine is this, and go to a hospital or go to a medical store, and then after it will identify this is for fever, this is for cough, this is for cold, and all that done. So we are having a model, that is abstraction model, which we have done in second part, and third part will for future work, that is for handwriting wala part we will use for the doctor one. So this is a generalization. Next is evaluation. So evaluation is done is a last model. It is a feedback model. Feedback, if there is an improvement in any model, or there is any wrong prediction they are making, accuracy is not getting accurate. So we are making up the problem arises if the accuracy is low. We will have, if it is making a wrong choices, that it is not going like this, you have to go left, or but it will go to right. So it will make a feedback, and then making to it that next time this problem arises, it will go to the right direction, not to the left direction. Okay, so this is the feedback we are having to it. So learning process, we are having a four thing, that is data storage, the abstraction, we are having a generalization, and that is a evaluation. These are the four models. So we are going for learning also, learning process also. So this is arises a machine learning, artificial intelligence and deep learning. So deep learning, the AI is a superset of all the machine learning and deep learning. So this is a superset, then this is a subset, and this is a inner one, that is a deep learning. This is a relationship between the AI, ML and DL. So what is a machine learning? Machine learning is when we are this is a Arthur definition of the 1959. That is a machine learning is a ability to learn. A computer will learn by itself without explicitly program. You will not give any program and they will learn from the experience, that is a past experience. Any task this is given to it, they will learn according to that as a past experience. They will train a model, they will build a model, and then after, if any problem arises, if the accuracy is not up to the mark, they will make a feedback out of that, and then after in the next time they will ask the same question, they will not give a wrong answer according to that. So this is our proper definition of a machine learning is कि machine learning is the ability to make a decision by itself by not explicitly programmed by outside. So these are the definition of the machine learning we are having. There was other definition also, that there was any past experience we are having, we are making a prediction according to that, and we are having a feedback. So that is, we are having a build a model by the past experience, and past experience we are having, and then after what we are having a new data. We will see the new data. If the new data they are having a giving a right answer, okay. If they are not giving a the right answer, they are giving a wrong answer, they will go to a feedback, and then after they will make a update this model, and then after next time they will ask the same question, then they will give a right answer according to that. So this is a machine learning model. We will design it. So you will learn about what is a machine, this is learning, what is a learning process, what is a machine learning. Next, what we have this is a model. We have this past data and experience, that we have make a data machine learning algorithm, building a model. Machine learning algorithm, we are having a supervised algorithms also, unsupervised also, reinforcement also. What is supervised? Supervised, in which we have a label data. That way, if A is come, then you have to go in class A. If B is come, you have to go in class B. If C is come, you have to go in class C. So all the label data has to be there into a supervised learning. So there was any label data. Unsupervised learning, they don't have an label data. So you will make a clusters. Example of this is machine learning in unsupervised. When you make a clusters of it, clusters like what we have similar data. When I am saying that in class you are having A to K, they will go in class 1. K to the name start from A to K will go in class 1. K to M, they will close in class 2. Otherwise, other option will go to class 3. So we are making a similarity that according to the name of initial name itself, that A to K will go to class A, A to K with class A, and K to M will class B second, and M to you will have MN, you will N others, that is Z to class 3. This is supervised. We are making a similarity according to the initial of the name. And then when we have a category of A, B, C by the initials, they were making a 3 categories, that is on the initials, A to K, L to M, N to Z. We are making. So this is a unsupervised learning. We are not having a label data into it. Next is reinforcement learning. We are divided machine learning in 3 parts. Third part is machine reinforcement. Reinforcement learning is what we are having when we have achieved something in general life also. When a small child is doing anything and that is achieve something, the first prize, any competition, anything else. So we will award them. If they are not making any if not, if he is not participating, so we will make them, no, you have to participate in this competition. If it's positive or negative, the other side, if you win or lose, other side, but you have to participate it. So when you are getting a award, on the basic of, when you are getting award, you will get awarded, matlab you have win. If the computer win, you will get awarded. If you are not getting, you will give a punishment also. This is called a reinforcement mention. Jab you are doing good thing, good work, appreciated. If you're giving a negative thing, not doing anything, if you are making lazy, you are not doing your work, all this, you will get a punishment according to that. So in school also, in colleges also, what we have a reinforcement learning we are using. So according to that, we will make a model. According to that, any of them, and then after we will make a data. If the output we are having, if that output is accurate, accuracy is good, okay. If it's not good, we will make a feedback, and feedback will update the model, and then after we will make it a workable model. So this is learning process, machine learning, what will we are having. Then is a superset of machine learning is a AI. AI is what? Artificial, that is man-made, not the human-made. That intelligence, matlab you are making a thinking power. So you are making the computer to think like human. There's a human is taking decision like this, you have to do in situation this to this, this to this, this to this. If you are not safe, you will call your at home. If you are not liking any process is going into, you have to do this. Your mother and father is guiding you all the time. But in that, the guidance is replaced by the man-made that process, that is a machine, and that is a learning, that it will thinking that. So this is a that is a main or fast growing field which is new technologies day by day. So this is a revolutionary to us. The man-made thinking power we are using here to us. So we are having a AI. This is a computer science where the computer will think like human, without the intervention of human. He will feed according to that and make decision according to that. They will solve a problem in reasoning also, problem science, computers, every problem in we have received that. So we will see that why AI, because there was many problems arises into softwares also. There is healthcare also, trafficking also, marketing also. We are having a AI in a, that is a person virtual assistant, that is Google Assistant, Siri, that we are in iPhones, that if we want to call anyone, so we get Siri, hey Siri, just call on speaker. So that we will not, don't go out to the phone, and we will say to Siri, and then it will make a call, and then after we will answer it according to. So with that, with the robot, but we are working in environment where we are having a human at risk. We are making a robots with the help of AIs, but it is making a fear of risk to that the human will take us to that, because we are making robots, not robots are making us. So that is a fear of using AI in our field, that we are having a risk of to human is little bit there. So we are not, because they are making a thinking process. If they are making a thinking process, they are manipulating any other thing, they are making a human at risk, they are hurting us, they are making processes, they will restart any process. So this is not done by the AI. This is not the main aim. The main aim of the AI is to make the human, to make suitable to human, to make human, to make all the complex problems solved by AI, and that the human will do other things also. So that is a helping hand for us AI, but not the risking process to us. So what we are next, we are have a deep learning. Deep learning is like human brain. Human brain, we are having a signals, that is neurons. One neuron is connected to other neuron is connected to other neuron. So all these neurons are connected, and we are giving our signals according to that. So one signal is giving to other to other. So this is a replica of what we are having in our brain, that all the neural networks, and we are making that as as is used for the machine learning also, that neurons are connected to other others are others, and which we make a neurosystem, and then after we are making a to solve a complex problem, that we are having a deep learning problem, what we are having, there was limited version. So in this we are having a input and output. There was also a hidden layers. All these layers are hidden. The more the hidden layers, or more we are having a complex to solve the complex problems, and it is the accuracy is also high according to that. So these are the in the input and output we are having the hidden layers, that is used for feature extraction, hidden parameters also. So that the V is used for the complex problems we are having into day-to-day life. So what are the application of machine learning? Machine learning is used in retail business also, but that Amazon also is doing, Flipkart is also doing. They want to make a profit day by day, have to make sale. So what they are doing is study the human behavior, and then after they are making according to that. The Diwali pay, you are just having a sales. Diwali pay, you are having a prices down. They are making this is an attraction to them, and they are making business of it. In the finance also, they are having a finance also. There's a the bank will analyze the data, that is building model, and we will say that credit application, your fraud detection application. When you're giving a loan, you will have a credit score that you okay. This is the person, you will have applicable of 10 lakhs loans, 20 lakhs loans. You will apply, because by checking their background, their saving accounts also, their transactions also, their career point, their age group, all these factors has to be evaluated by model, and then after they will send it, yeah, we can give a loan also. In a manufacturing also, we are having an optimization problem also, control and troubleshooting problem by the machine learning. We are make a model, and then after we will optimize it. Medicine also, by using a learning model. Medical diagnosis, in an example like when we are having a initial stage of diabetics. So what we are having, we have a pain in legs, we are dizziness, we are having a sugar levels high, fasting or before fasting or after food also. So all these are indications. So before going to a doctor, we will have a initial diagnosis by us, by the machine learning model, and then after we will give a medical thing that you will go to this side, you will go to this, by using you will cover lifestyle. They will also guide us. You will change the lifestyle. You will take this, you will like this, because they are sugar like this. They will make a model according to, and they are having a profit of it. So this is a scope of medicine of machine learning is. As a telecoms, we have a maximizing, optimizing the quality of problems we are having. In science also, we are having a constantly working on physics, biology on that. In the artificial intelligence also, we are having a teaching models for the forecasting and all that. To find a robotics also, vision and speech recognition also. So we are having a control devices which is human, not human run also, that is automation running also. So all these are the application of the machine learning we are having. So we are well-defined problems. We have category of performance, task, T, performance, and experience we are having. So all these are, I have discussed earlier also about the learning process. So well-defined problem is spam or not spam. You have a category of spam or not spam on where in your Gmail account. You will have, if you are saving that any email consists of discount, free, all that has come into spam. Otherwise, it is not the spam. Checkers. We are having a chess also, the checkers game also. Handwritten, we are having this. It's like A is also. This is also A. This is also A. So handwriting recognition. Self-driving cars also by the robots also. So we are having that thing also. Fruit key prediction. This is apple. This is mango. This is according to shapes we are as. Face recognition by taking attendance. This is application of this. Okay, face recognition. You have put in classroom, and then after the person will come, they will face recognize it and go for attendance. This is an application of machine learning. In automation translation, Tamil to Tamil to English, English to Tamil, Hindi to Spanish, all the language translation, one to another we are having. So this is a learning a design model. We are have to be this the 4, 5 categories of steps we are having is choosing a training element, experience, target, experience, a representation of target, functions, function approximation, and final model. When you're designing a service model, what we have training model, that is training experience. We are having a data for it. The data has to be modeled because we have to make a failure or success or failure according to that by choosing a training experience. The training experience is labeled, then the data has to be failure. Failure rate is less than success rate is high. So by making us choose a wisely training experience according to that, to train any model, to build any new model to it. So these are the example of, then we have a targeted model. When we are, for example, we are playing a chess. So that chess has to be the opponent with the computer and the, you are playing between computer and you. So the computer will think according to that, this is my aim is to success. My aim is to defeat this person which is playing with me on a laptop or in a phone. So that is they will making evaluated that, okay, if this move is this, then we have to make this legal moves and all to get a success of it. So this is a targeted function which is evaluated by the chess mover also. So this is a representation. Then what are the possible moves that was optimized to make a success? Because end of the day, the person computer have to make a success of it. So what is 4 moves, and this is the optimization. The person will draw like this also, then move this like also this, right? So all the possible ways is evaluated by the computer, and then after it will move. Okay, if this move, so I will defeat like this. If this move, defeat like this. So all that make, because the rate is, that is a target function of it, is a success rate of it. Approximation algorithm also. The approximation function may, how do we do this? That we have to get a success every way. Next move, we will move a success of it. That we will optimize it, making an approximation of algorithm. Final design is intelligent ML model. We will design it, and then after that we will play with the computer and the expert also. So what we are having in our is machine learning process, well-defined problem also. What is AI also? AI is a superset of it. The ML and deep learning is a subset of it. How is the process of making any problem to a machine learning problems? What are the experience with it? How can we model it? How can we train it? We have a feedback of it, all that designing model, and then after make a design, final design of it. Okay, then this is our presentation. Thank you.